Alright lads, I'm going to go through some bearing stuff for you. So this is following on Mr. Bell's Year 10 lesson on bearings. So basically what I've got here is I've got 8 problems. Now each of them I'm just wanting to know what is my bearing. This is a really important skill set to have if you want to attain those higher level grades in trigonometry, because those excellence questions are usually based around something a bit more abstract, and bearings is a good place for most assessments to go. So without further ado, we'll just get cranked into one. So all we have is this angle, so it's 50 degrees, but I want to know what is this bearing. So from Mr. Bell's video lesson, we always take our bearing as the angle measured from north. So we just want to know what is that total bearing there. And so we know that this is 90. And so if that's 90 plus 50, then we must be at a bearing of 140. So our bearing here is 140. So if I was standing at the origin, I would have to turn around, I'd have to turn 140 degrees to look in that direction. So that's the bearing that direction is in. So if this is 10 degrees, then what must this total angle be all the way around there? Well, we know that a full turn, if we're looking north and we turned around 360 degrees, we'd still be looking north. So this angle here, well, that's 90 minus 10, so that's 80 degrees. And so it's 360 take away 80, so we must be 360 take away 80, what is that? Is that 280 degrees? So that bearing, you would turn 280 degrees from north to look in that direction. So this bearing is 280. What is this bearing? Well, this is 45, and because it's 45 in a right angle, this must also be 45 degrees. So if that's 40, this is 45 as well. So a bearing is 45, right, from north. And there's a subtle difference with bearings and degrees. Bearings is always 3 digits long. It's 3 digits so that you know that you've taken a bearing and that there's no confusion between what the bearing is. So our angle from north here is 45 degrees, where our bearing is 045. So if you were standing here and your mate was standing here, you might tell them that you were at a bearing of 45 from them. So this bearing is pretty similar. That's going to be 020. You're at 20 degrees from north. So you might want to give these ones a go now. So all the way around to here. Oh, I think this was meant to be 30 degrees, by the way. So that's 180 around to there. So if I was someone standing here, I was looking north, and I wanted to look in this direction, I would have to turn 180 and then 30 to look in that direction there. So 180 and 30, that is a bearing of 210. This bearing is 90, and we know that this angle and this angle must add to 90. So this angle here must be 15 degrees in there. So this bearing must be 105. At a bearing of 105. So from north, I am looking down 105 in that direction. So always think that you're at that point when you're looking for that bearing. This is 80, so this angle here must be 10, and so this bearing must be 180 plus 10, 190. Okay, this one here is very similar ones before. We can just read straight off. Our angle from north is 15, so 0, 1, 5, 0, 1, 5. And that is our bearings. Okay, so there's some basic bearing introduction. Now let's try and apply bearings to some problems. So I've got a couple of problems under here. So let's have a look at these two. So Hopefully you can read it, but it says a boat sails south from a port for 14 kilometers. So let's just make that north, just go north up the page. And it's traveling south, which is showing it's going straight down for 14 kilometers. Another boat sails at a bearing of 235 degrees. How far must it travel to be directly west of the boat? So we're gonna have to draw this up. So let's go port, and let's go boat 1. B1, boat 1. It sailed directly south, how far? 14 kilometers. Now another boat sails at a bearing of 235. So if that's north, they both leave the port at a bearing of 235. Well, 180 is what the first boat's done. Now 270 would be going this way, would be going west. So it's kind of, I'm just going to draw it roughly, it's kind of in this direction here, isn't it? That is a bearing of 235, and now it's sailed until it's directly west of the first boat. So if you're on the boat and you looked west, you would now see B2. So if it's done a 235 degree bearing from north, it's done 235 all the way around there, hasn't it? So if you're standing at the port, you would be looking at that boat at 235 degrees. And so what's this angle here? Well, 180 would get you to there, and so that means that this must be 180 means we can have 20 and 35. It's a 55 degree angle. And if you're thinking this is a right angle triangle, you're correct, because it's directly west. So that would make that a right angle triangle. And so notice now that just all this information, all it's done is give us a right angle triangle, and we want to find that length there. So we're going to right angle tree. Label our sides. So this is H and this is A. It's beside the angle, and this is opposite the right angle. So we're dealing with cosine. So cosine 55 is equal to A over H. 14 over X. Our unknown is on the bottom, so we can simply do the swap. So X equals 14 over cosine 55. So X equals, let's put this in our calculator, 14 divided by cosine 55 equals 24.4 kilometers. So that boat, that meant that it had to travel 24.4 kilometers at a bearing of 235, so that it was directly west of that first boat. So what do? We just drew up the direction of that first boat. It just went directly south from the port. We then knew that this boat went on a bearing of 235. So it's not 180, and it's not all the way around to 270. It's somewhere in between. So then we just drew kind of a rough diagram of where that second boat went until it was directly west, and then we noticed we had a right angle triangle with an unknown, so it's just some trig. Okay, let's have a look at this one now. I walked 5.2 kilometers in a northwesterly, let's go, in a northwesterly direction until I was 4 kilometers north of my camp. What is my current bearing? So we're gonna go camp, and I've walked northwesterly, so north, east, south, and west, and I've gone north in a northwesterly direction, not exactly northwest, but northwesterly. So we're just going to kind of go for a kind of not random but pseudo-random kind of line up here. So I've traveled in a kind of a direction like that, and I've noticed until I was 4 kilometers north of my camp. So 4 kilometers north. So I know when I'm at this point, I'm 4 kilometers north of my camp, but I've traveled 5.2 kilometers, and I want to know my bearing. So I'm going to have to figure out what this angle is. because if I can figure out that angle and I take it away from 360, I take that out, that'll give me this bearing, won't it? It'll give me what direction I'm looking at from north. So from north, what is that bearing going to be? What is this big angle going to be? So I figure out this one here, let's call it theta, and I'm going to label my sides. So right angle triangle, H and A again. So cosine of that angle theta is going to be equal to A over H, 4 over 5.2. I just want the angle, so I do cosine inverse 4 divided by 5.2. So shift cosine, because I'm doing the inverse of the function, 4 divided by 5.2, and I'm going to close that bracket so that it acts on the division itself. And I've got 39.7 degrees. So that angle's 39.7, but I want my bearing, so I take that out of the 360. Bearing is 320. We'll just call it 320 degrees is that bearing. And so that would be really handy. Say you know your distance north from somewhere, you know your total distance, you will be able to tell someone what bearing from the camp. So that's actually really helpful for someone knowing, so someone at the camp would then know to find you. They just have to travel at 320 degrees in a straight line and they will catch you there. Cool. All right, I've tried to create an example problem from a current popular video game. It is Warzone, right, Call of Duty Warzone. So what I've decided to do is I've got a mate at the military base and I've got a mate at the stadium. Now, they've pinged, one person's pinged directly south and one person's pinged directly west, all right, at the Great Bridge. Let's say that's at the Great Bridge, which probably is a roundabout. So Great Bridge, that's where they're pinged. That's the Great Bridge there. So what I wanted to understand was how far, well, we could do how far apart they are because it's a right angle triangle, but I want to know the bearing that the person at stadium would have to walk to get to the military base, and I want to know the bearing that the military base would have to walk to get to the stadium. So what I'm going to need is I'm going to need this angle in here. So if I need this angle, because remember that's north, so I'm going to add this angle to 90, 90, 90. So I'm going to add that angle to 270, and it's going to give me my total bearing that I'd have to walk in the direction of to get to the military base. So when you ping, you get given your distance from that ping, and so they've both been given that distance. So we just need to label this triangle. So this triangle is going to be O and A. So we're using tan. So tan of that angle is going to be equal to O over A. And so we want the angle, we tan inverse the 1400 over the 850. So inverse tan, 1400 divided by 850, we get an angle of 50, I'm just going to call it 59. These it's not a very vast distance, and these are actually quite big, so I reckon I can get away with going and calling that 59. Just having a little bit of deviation there over a small distance shouldn't be too bad. So 59 degrees. So if I was at the stadium, my bearing would have to be 59 plus 270. So I'm walking at 329 degrees. That there is at a bearing of 329 degrees. So if you're at the stadium, maybe check this you could probably check this in game. Stand at stadium, look over at military base, and at the top of your screen, there might be some bearings. I'd be interested to know if that's close to 329. I've kind of just made up these measurements, but they make sense. So if this person looks at 329, what bearing does this person look at? Wow, we could make this. That would also be 59, wouldn't it? So 59 plus 90 would be 149. So this bearing is 149 degrees. So remember, that's north. So your total angle from north is 149. So if you were to meet halfway or meet somewhere on that line, if you're standing at stadium, you would want to travel with a bearing of 329 degrees, and this person would travel at a bearing of 149 degrees. Now I got that 59 because alternate angles on parallel lines are the same. Now there's another way you can get that bearing. If you had this bearing of 329, if you take away 180 degrees, okay, so 329 minus 180, you should get the same answer, shouldn't you, as what I've got up here. It's because if this person walks at 329 degrees and then the other person is in the opposite direction, well, that's just 180 degrees, isn't it? So now back this way. So you take 180, you're going in the opposite direction. So that's the bearing that they would have to walk in. So hopefully that clears up a bit of that bearing stuff. If you were to go through a couple of problems again, you'd probably want to go through those too. Yeah, let me know how you go.